Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today we are going to discuss about deterministic finite state machine. Just join quickly and mark your presence. I once again welcome you all to my session. So I hope I am audible and visible to every one of you. Am I audible? So please confirm me once if my audio, video, everything is clear. Yeah, just confirm me once. Okay. So hello Tarun. Good evening. Hi Sahil Malik, good evening. Is my voice clarity and everything is fine? Okay, so now let me start the session. Yes, before I begin the session, my session is today Deterministic Finite Automata. So before that, I will just let me know about myself. Myself, Muralikrishna Sir. I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I am topper of different NPTEL courses and also certified as international engineering educator, and I have mentored more than 50,000 students across the country in different core areas of computer science, which includes theory of computation TOC, operating systems OS, computer organization and architecture COA, computer network CN, digital logic design DLD, and information and communication technology ICT. So this is about my brief profile, and before I begin the session, please do share this class information with your friends, and also please do like this session and subscribe the channel if you have not yet done the subscription, and also just press the bell button for getting notification related to the classes. So we are providing free classes related to GATE 2024 fundamentals and also NILIT classes, some generic sessions we are providing, and also post GATE guidance and preparation strategies. So different types of classes we are providing. So please do subscribe the channel for getting benefit of all this. Yes, hi Nazmeen Khan, good evening. Yes, I hope my audio, video, everything is clear, and I'm just about to start the session. So meanwhile, you can just share the information with your friends. Okay. Now coming to a free workshop we are conducting. So this is regarding 5 points you must know for GATE 2024 preparation. It is on 2nd May. Okay. So 2nd May means tomorrow only at 7:30 p.m. By Richa Gupta madam. She is having MTech from NIT Raipur and she is having 5+ years of experience. So please join for this workshop and register for this workshop. Okay. Now coming to GATE toppers of 2023. These are the results of 2023 GATE, and we got 62 students under All India rank 50 and 10 under All India rank. Actually 13 students under 10 and 107 students under 100. And these are some of our toppers. Dhruv, Gautam and Sir Verma has got All India rank 5th, 1st and 4th, 5th respectively. So please just shall I continue? Okay, if you have any doubt or concern, please let me know in the chat box. And even after the class is finished, the comment box will be continued to be answered for all your doubts. Whatever the homework questions we are giving, you can just discuss those homework questions in the comment box. Okay. Yes. Shall I start? Please respond in the chat. Okay, fine. Now coming to finite automata, which is of deterministic and non-deterministic. So already non-deterministic finite automata we have discussed in the previous session. So and solving of problems related to NFA, and we have also discussed the difference between non-deterministic and deterministic, and once again I will just explain. In a non-deterministic, we will have multiple transitions and for multiple inputs, 0 or more transitions are possible, and we have to choose one path among many paths. Whereas in deterministic, there is exactly one path, so we can determine exactly whether the string is accepted or not accepted. Yes or no, we could say exactly. But in non-deterministic, we have to see by exploring different possibilities. That is making difference between deterministic and non-deterministic. So basically, for every input symbol in a DFA, there exists an exactly one transition from any state of the finite automata. For example, there are two states, something like Q0 and Q1, let us suppose. Just assume. Okay, and Q0 is initial state and Q1 is a final state. For suppose. Okay. if the inputs of alphabet are something like some a comma b, for example, okay, and q naught state should define a transition with input a as well as input b. Similarly, q1 also should have a transition with input a and input b only once. Exactly one transition for one input over any state. So for it means, let us suppose q naught on a if you define here, and there should not be any other a, only one a. If a q naught on b is defined for this, only one time you have to define. Similarly, q1 on a if you define here, that's it. And q1 on b if you define to here, that's it. So that means two states are there. There are two inputs, 2 into 2, total 4 transitions are possible. Total 4 transitions are possible. So for every input symbol in DFA, there is an exactly one transition from any state of the finite automata. Okay, that is what deterministic is. So exactly transitions will exist like that. And DFA covers, as I told you, deterministic transitions for all valid and invalid string. Invalid in the sense which is not in the language but same alphabet for a given regular language. So whether it is a NFA or DFA or NF epsilon most, all these things are recognizers of regular languages only. Okay, it can't recognize non-regular languages. The power of finite automata is the capacity to recognize regular languages, and it accepts the string by halting at a final state and rejects the string by halting at a non-final state. Okay, so halting in the sense, let us suppose I am taking A, B, for example. So A, B, there is exactly one path and it is halted at non-final state. So this won't be accepted. Similarly, if you take something like A, B, for example, A, B, it is halted at final state. So it is recognized. So it is accepting odd number of B's over any number of A's. Okay, so this is how the DFA condition is. What is the DFA condition? Every state should have all inputs, but only one transition for one input. Multiple transitions are not possible. Okay, now coming to representation of DFA, it is just like finite automata containing a set of states, set of inputs, transition function, initial state, and set of final states. It's a tuple machine where Q indicates finite set of states, sigma is the finite input alphabet set. So finite number of inputs will be there here, and delta is a transition function which is defined like this. So state and input will give you only one state. In NFA, the difference is like this. In NFA, what is the delta? Delta is from q cross sigma to 2 power q. That means state and input can have 0 or more transition, power set. This is NFA. In the case of DFA, for one state and one input, there is only one transition. Delta is from q cross sigma to q. One state and one input should have only one transition. That is what defined here. And q naught is the starting state, which is a subset of set of states, and f is the set of final states. So f is the subset of set of states. That means all the states can be final or some of the states can be final. Okay, so there can be a final state in the finite automata, which is to accept the strings. And if you have a doubt, please ask me, and please do share with your friends and subscribe the channel. And I am going to solve different typical problems in the DFA today. So requesting everybody to please share the class information with your friends. So around 8 to 9 problems I brought. So I will let you know how to construct the finite state machine today. Okay. Shall I continue? Hope I am audible and visible to every one of you. Yes. Okay, fine. Now coming to, okay, yes, Sahil Malik, thank you for your response. Fine. Now coming to example of DFA, let us suppose I am having something like this. Language L is equal to some a power n, b power m, such that n greater than or equal to 1 and m greater than or equal to 1. So these are the two things, for example. Okay. So in this connection, how to construct a finite state machine for it? I will explain. So what are the strings here? One or more A's followed by one or more B's. In the case of regular expression, minimum 1A followed by any number of A's and minimum 1B followed by any number of B's. A star, B star. So we can have a strings like AB and AAB and ABB, AABB, triple AB, A triple B, and so on. These are the strings. Okay. So in these strings AA star, BB star, we can have a machine like this. So minimum we will have 1A followed by 1B. So minimum AB is accepted. For AB it will go to final state. Okay. And let us suppose this is a state A, this is a state B and state C. So we are having minimum AB accepted, and A and B and A it will go to A because A star, B star. And actually on the state A, B is missing because we are not supposed to start with B. In that case, we have to define a dead state. In this case, we have to define a dead state. So what is a dead state? Dead state is a non-final state which will be there in some of the DFAs, not all the DFAs. And it will have only incoming edges, no outgoing edges. For example, D is a dead state. A and B is missing, it will go to dead. And B, state B, input A, input B both are defined. State C, input A is missing because after B, A should not come. So state C on input A, it should go to dead. And dead state on input A is dead and B is dead. So this is the DFA. Now if you see the transition delta of this DFA, it is like this. Delta transition function, it is like this. Input A, input B. And states are A, B, C, D. Okay, state A, input A, it is B, and input B, it is D. And state D, state B, input A is B, B is C. State C, input A is D, input B is C. And state D, input A is D, B is D. So for one state, only one transition over one state. Why dead state is defined with all inputs? For example, if I wanted to verify whether the string something like AB, AA is accepted or not. AB, AA, it is going to non-final. That is a non-final. So it is not accepted. So path should be there. For every string, whether it is present in the L or not present in the L, path should be required. That's why we are defining the dead state. And one state, one input, we are having only one transition. Okay, na? So like that, we will define the transitions of L. Okay, na? Shall I go for the next example? Yes or no? So total we got 4 states exactly. Okay, now coming to next example. For instance, there can be some DFAs which may not require a dead state also. Something like, for example, L is equal to, so W says that W belongs to A comma B whole star, any combination of A's and B's, and length of W mod 3 is equal to 0, for example. So string length must be multiple of 3. So what are the lengths acceptable here? String length 0 is accepted, string length 3, string length 6, string length 9. So all the length multiple of 3. So epsilon, string length 3 means AAA, AAB and so on, BBB, like this. Should be acceptable. What is the regular expression for it? Length multiple of 3. So ARB should be written thrice. ARB whole star. So string length multiple of 3. So as a minimum string is epsilon, we can take starting state as a final state. Okay, na? And string length 1 you should not accept. 1 means either single A or single B. Non-final state. String length 2 you should not accept. This is also AA, AB, BA, BB. This is also non-final state. String length 3 you should accept. You should go back to the final state. So A or B. 3 accepted, 4 not accepted, 5 not accepted, 6, like this it will go. This is a DFA. Okay, it satisfies all the conditions of the transitions, right? So this is string length multiple of 3. Okay, and now coming to significance of dead state. Already I told you, dead state is a non-final state, and it is there in some of the DFAs, not all the DFAs. Dead state is a non-final state, it will have only missing transitions. So I will tell you one example. Let us suppose we are having something like language is A of B a whole star, for instance. This is also string starting with A. So we can have a strings like A, B, A, okay, A, B, A, B, A, like this. We can have the strings like this. So in this, if you construct a finite state machine, it is like this. Minimum string accepted is A. Minimum string accepted is A. So Q0 to Q1 there is a transition, and A B A. So you can give this B back to Q0. So A accepted, A B A accepted, A B A B A, like this. Now there are all strings recognized, but there is a need of dead state because for some string, for example, string like AAB, no path is there, na? Zero path. But how do I say whether it is accepted or not accepted? That's the reason we have to define a dead state. So Q0 on B missing, we will send it to dead state, and a Q1 on A missing, we will send to dead state. And dead state is not for all the languages. Please remember. Okay, is for only for some languages like this. So A comma B. So whatever the string you take, now we can show whether they are accepted or not accepted, because it will show a path for every string. It will show a path for every string. So A slash B. So A B now path is there. A B. Now for example A B B A also path is there. A B B A and B A B. Any string path will be provided, but only the language strings, it will have a path to final state. For other strings, non-final state, including a dead state. Okay, dead state is a non-final state where it will have a transitions of only incoming. Once if you go there, transition dead. We cannot come out of the dead state. Okay, that is the criteria. Now coming to some problems construction. Construct a DFA that accepts all binary strings. All binary strings means sigma is equal to 0, 1. Binary strings are zeros and ones. So 0, 1 should be accepted. Binary string means 0 is a binary string, 1 is a binary string, 0, 0, 0, 1, 1, 0, 1, 1. All, any combination of strings. So very simple. Actually, minimum 0 or 1, then followed by any combination of zeros and ones. So we can have the string like this. 0 or 1 is acceptable. 0 or 1, it is going to final state. And after that, let us suppose Q0 and Q1. Any string is accepted. So we can give a self loop 0 or 1. That's it. So transition will accept only one state for one input. Q0 on 0 is Q1, 1 is also Q1. Q1 is on 0 is Q1, 1 is also Q1. So this is the expression 0 or 1 followed by 0 or 1 whole star. Two states. You can also give like this, but it will accept epsilon. If you give like this, epsilon also will be there. All binary strings will come, but epsilon is not a binary string. So he specially mentioned that all binary strings. That's why I have taken like this. Okay. Now coming to next question. Construct a DFA that accepts all strings of A's and B's over the alphabet sigma is equal to A comma B, where every string is starting with A. That means ending can be either A or B, but starting is A. So what is the expression here? So starting with A, we can have any combination of A's and B's. So here there is a need of dead state. So from the starting state, for example, Q0 is a starting state. There is no epsilon here. What are the strings present here? A is there, AA can be possible, AB can be possible, AA can be possible, ABA can be possible. Any string of A's and B's starting with A. So once if we start with A, it can go to the final state followed by any combination of A's and B's. So there is a dead state. Q0 on B, it will go to dead state because Q0 on B is missing. So dead on A is dead, B is dead, like this. These are the things. So construction of DFA that accepts all strings of A's and B's over alphabet sigma is equal to A comma B, where every string is starting with A. Any doubt you could ask me here. Okay. Now coming to next question. And some questions, whatever the question I have given homework, even in the last class also, I will discuss the solution in the chat box, not chat box, comment box after the class is finished. Okay, you try it first, and if you don't get, you can just ask me in the comment box, right? I hope everybody will make use of this facility. Okay. So shall I continue? So construct a DFA that accepts all strings of A's and B's for the alphabet A comma B, where every string is ending with B. Ending with B means, so minimum string is B. We may have AB or we may have BB, AAB, ABB, BAB, like this. All combination of A's and B's ending with B. So it is nothing but A plus B whole star B. A plus B whole star B. Strings of A's and B's ending with B. So it is like this. Ending with B, I am just taking minimum string accepted is B. Q0 on B, it will go to Q1. Okay. Then after that, any number of B's can be acceptable. So B accepted, BB accepted, any number of B's ends with B. And before that, if you give A, actually if it is NFA, A or B will be given at Q0 itself. So only A, because multiple B's it can't take on a same state. AB accepted. For example, if you want BAB, so A you can go back, because if you give A to the final state, it will end with A. It's fine, right? So what are the minimum B? It is accepted. And AB also accepted. AB. BB also accepted. Any number of B's. AAB. AAB. ABB. ABB. And BAB. BAB. Any string ends in B are being accepted. So one state, actually if it is NFA, we would have given like this now. NFA would have given simply just ending with B, and before that any number of A's and B's we can give as a self loop. It is NFA. Okay. So in the DFA, delta is defined like this. So Q0 on A, it is a Q0, and Q0 on B, it is Q1. And Q1 on A, it is Q0, Q1 on B, it is Q1. That's it. Okay. I hope you got my point. Okay. Now let's move on to the next question. Question number 4. Construct a DFA that accepts all strings of A's and B's over the alphabet A comma B, where each string contains substring AB. Substring AB means presence of AB is required in every string, and before this AB, any combination of A's and B's can be taken. After this AB, any combination of A's and B's can be taken. So A plus B whole star AB, A plus B whole star is a regular expression containing substring AB. So this type of problems we can do very easily. So you can check AB minimum string, and AAB should accept, and AB should accept, even ABB can accept, ABA can accept, and AAB can accept substring AB. Anywhere presence of AB is required. Very simple. Just observe here, everybody. So first of all, we can do like this. So A, Q0 on A, it goes to Q1, Q1 on B, it goes to Q2. So AB is accepted first. And before AB, any number of B's we can take. So B we can give a self loop. And even AAB kind of string also can accept. A we can give A self loop here. Okay, and then after that, any combination, after AB, any combination of A's and B's we can take like this. If I don't give self loop, we can't get string like AAB. Even BAB also accepted. AB, BA, AA for example. It won't accept it. AB, BA, AA. No dead state is required here. Okay, same. For example, if a DFA is given for ending with AB, for example, it would have been different. Here itself, I will tell you, so you'll understand clearly. If an expression is something like A plus B whole star AB, for example, all combination of A's and B's ending with AB, then the DFA would be different. It is like this. We can take minimum what is AB. Same combination we will consider. AB is acceptable here. Then before is any number of B's, we can have AAB, and we can have AB also. AB, A you can give back. AB, and B if you give self loop, if you give B self loop, ABB will be ending. It's a problem. If you go back to this, same is a problem. You can send B to the starting state. So this will accept all the strings ending with AB, like AB, 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 B. It won't accept because it don't end with AB. This is different. This language is completely different. It is ending with AB. Just for comparison purpose, I have told you this. Okay. Now coming to example 5. Construct a DFA that accepts all binary strings, all strings of A's and B's over the alphabet sigma is equal to A comma B, where each string starts with either AA or BB. Can anybody tell me how many states will be there for this? Can anybody try? How many states? And please do like the session and subscribe the channel and do share with your friends. Okay, so first of all, please let me know how many states would be required. What is an expression here? Either starts with AA or BB. When you start with either AA or BB, it can be followed by any combination of A's and B's. That is A plus B whole closure. AA or BB followed by A plus B whole closure. So what are the strings present here? Minimum string is AA. Next BB. AA followed by B or BB followed by A. AA followed by A. So starting symbol two symbols are definitely BB or AA compulsory. That is must. Okay, now let me verify this. How many states would be required? So definitely if I am taking Q0 on A to Q1, single A should not accept, single B should not accept. And for 2 A's, it should go to final state, which is Q2. AA accepted. Then after AA, any combination of A's and B's. Same is the case. For example, B if I am giving to Q1, BA will be starting. So we have to take another state, some Q3, which is non-final. So we can take B to this and BB. If I am giving like this, it will go to this. And please remember, always it should start with AA or BB. And here Q0 on A and B is considered. Q2 on A and B are also considered. What are missing here? Q1 B missing, Q3 A missing. For example, if I give B, AB will be starting. Okay, so it is something like this. So AAB is accepted. So definitely, if B is given back to this, for example, A, B, A, B, AA kind of string, A, B, AA kind of strings will be accepted. So we can't give back to this. We can't give B to this also. If we give B to this, AB will be ending. If you give A to this, BA will be starting. Starting should be AA or B. That's it. So we have to define a dead state. What is missing? Q1 on A is missing. Sorry, B is missing. And Q3 on A is missing. We can give a dead state. So A or B can go to the state. Yes. Total 5 states exactly. One dead state is required. Exactly. Sahil Malik, Lalit Yadav, good. Very nice. Hope every one of you are enjoying the session, right? Is my audio, video, everything is clearly fine? Great. And please do share the class information with your friends. Don't forget. Okay. Fine. Now coming to next question. Construct a DFA that accepts all strings where each string contains 0, 0 as a substring. So I will give you a regular expression for this. I'm just giving you as a homework. All of you please try to discuss the DFA in this comment box after the class is finished. So for everything I will give you regular expression. Then DFA I am leaving it to you as a homework. In the next class I will explain, and comment box also I will explain. Containing 0, 0, 0 as substring. So 0 plus 1 whole star, 0, 0, 0 followed by 0 plus 1 whole star. This is the regular expression. And construct DFA that accepts all strings where each string not containing 0, 0 substring. Very simple. This is changing final to non-final and non-final to final of the previous DFA. You will get that. And eighth one, construct a DFA that accepts all strings where decimal value of string is divisible by 3. So what type of string should be accepted? Decimal value of string. That means alphabet, it is a binary string. So alphabet is 0, 1. Binary string, decimal equivalent should be divisible by 3. That means decimal values 0, 3, 6 and 9, 15. These numbers equivalent binary value should accept. That means 0, 0, 0, 0, 1, 1, 3, 1, 1, 0, 6, 1, 0, 0, 1, 9 and 1, 1, 1, 1, 15. This type of string. For this you have to construct a DFA. Okay, this also we'll discuss in the comment box. Try to ask your questions and construct a DFA that all strings of A's and B's over the alphabet A comma B, where each string contains second symbol from the beginning is A. Second symbol from the beginning means first symbol in the beginning is A or B, second symbol is exactly A and followed by any combination of A's and B's. A plus B followed by A plus B whole closure. So for this you construct the DFA. Hope everybody is in sync with me and try to just ask your questions in the comment box. I'll just help you in solving these questions. Okay. And question number 8, 9 and 7, 8, 9 are given as homework. So please don't miss these questions. Okay. Just for your practice I've given you. Thank you so much. And with this I'm concluding this series and I'll start one more series very soon, that is for computer organization. And I will just update the things in the chat box. Okay, in the Telegram group also. Okay, I hope everybody have enjoyed the session. Before I conclude, please do subscribe the channel with your friends and just share with your friends and do subscribe the channel if you have not yet done it and just press the bell button for getting notifications. Thank you so much. Thank you one and all. Have a good night. See you all. Thank you.